Let's get technical. Let's talk about EIPs.
Primarily, what I've been looking into is EIP 6228, which is the extreme ERC20 with meta transaction tokens.
High level abstract is instead of adding a gas fee on top of the transaction cost itself includes the fee.
There's some very big project contracts that I literally was falling off my chair the other day because I thought Brock was messing with me at first.
The main OpenSea contract where all of the millions of tokens that are minted on OpenSea come from, that's not verified, and they did the wrong transfer call.
I'm glad that nobody that has a podcast with a lot of listeners is exposing this kind of stuff, because it's like, you feel like the crypto industry is really making some serious advancements, and things like FTX are really terrible, but it's better that those things be known and these things not be as known, because these are trivial things that are like, there's no excuse for it. It's crazy. Hey everybody, welcome to Missing Links with John, Brock, and myself, Stephen King, where we discuss what's missing in Web3 architecture. For feedback, please go to missinglinks.fm, send us an email, give us some feedback on what we discuss and what you'd like us to cover next week. All right, let's get into it. Yeah, let's do it. So, hey everybody, welcome 2023, Missing Links. How you guys doing?
Pretty good.
Doing good. Happy to be back stateside with you guys. So my sleep schedule's not in order.
John, where did you go?
I just went home to Croatia. I went to Chicago, then to Croatia to see some family. Was up in the mountains trying to figure out what the hell to do with my wreckage of a house there. It's falling apart since the earthquake, but yeah, good to be back.
Since what earthquake?
There's two earthquakes in Central Europe and Eastern Europe back in 2020 and 2021. So I've been kind of using that theme to ignore my problem. So I looked at it, I made a decision, and then I left it for the time being. So I'll come back to it in May when I go back, pretty much.
Yeah, that's crazy. And Brachiosaurus, you did nothing but work. I know this because I've been following you on Slack and seeing the output. But you're
and Twitter. Don't forget about Twitter. Don't forget about Twitter. He's been active on Twitter.
So you're going to Hawaii. Which island are you going to?
Oahu. Yeah, friend's wedding.
Shout out to JJ. Congratulations, man.
Yeah.
I doubt he listens to this, though. But you can play him an episode.
Exactly.
All right, let's do it. So we thought a good way to kick off the year was to, well, there is news actually around FTX and everybody's sick of that. So let's get technical. Let's talk about EIPs because there's some really cool ones, and we want to go, kind of deep into them. So, John, any specific one? We've got about 5 that we have on the Docker.
Yeah. So primarily, what I've been looking into is EIP 6228, which is the extreme ERC20 with meta transaction tokens, so the MTT. Which is interesting because it almost seems like and Brock, this goes back to the days we were writing contracts when we were all working together about how do you transact without having ETH, or how do you transact and work within an ecosystem without actually having direct connection to that ecosystem. So this is very interesting because it's almost a cleaner version of the gas token, which we discussed the gas token many times before. Maybe I think back in 2018, summer of 2018, when we're all in New York and we're discussing how.
John, give us the 20 seconds on that real quick.
Yeah. So with the gas token or the ERP?
Well, we'll go into the EIP, but this was old school hacking stuff together with assembly lines and all sorts of fun stuff. So just give us the sort of snapshot on what we did then, and then let's compare it to this.
So back then we had a problem. So we had a solution to a problem, but that solution created another problem. So that solution was a way for individuals to interact with smart contracts and different real estate entities on the blockchain via data and voting. But to do that, they needed to have ETH. They needed to have a wallet. So we looked at different components, being a gas token, which was a way that you send a transaction. Think of it as almost like a proxy contract. That contract take the bytecode as well as the gas token and forward it and try to execute it. That way, you didn't have to actually have an individual sign a transaction and hold ETH. The system took care of that, and it was very messy. It was to your point, is a way of kind of hacking together a problem to kind of give a solution, but that created more problems down the line.
Well, it created economic an economic situation for us in terms of gas.
Exactly.
But the technology that you guys built was actually pretty sound.
It was sound, and we had a way. God, Brock, you might remember the name of it, but we had a transaction pool. I forgot how we did it, but we pretty much had a group of smart contracts, and for each individual user that signed on a platform, we rotated them into a signing pool, and that allowed us to forward gas to it. And this EIP, to that point, that system was great. But once we had these fluctuations in gas prices and fluctuations in ETH, especially when we had, what was it? I forgot. It was the beginning of 2019 before Denver. We had a spike in gas prices due to the Merkle tree testing and all that, that the whole system required us to pretty much put more into the system than was required because just gas was so high. Transactions were getting dropped left and right. So with this EIP, which is interesting about this, is it's actually baking in a protocol for MTT where the fee itself is taken out of the token itself via the standard, to my understanding, the standard transfer ERC20 protocol, which is pretty cool because instead of having to forward something to a contract, have the contract, and keep in mind, when you're forwarding something to a contract that has to execute something, multiple nodes could be potentially trying to solve that same hash, that same problem. So by having it all baked into one protocol where it's like this transaction, once resolved and solved, will take X amount from kind of a standard interface, it makes it very clean versus having multiple transactions that are talking to the same contract, trying to talk against multiple different tokens to resolve to some type of transaction. There's too many moving parts. This is a very simple, very concise way of taking kind of fees from individuals who are trying to interact with an ERC that don't have either that token or that kind of liquidity in their wallet, let alone a wallet itself. So I find it quite fascinating. I have yet to see how it would work in principle, since this EIP has not been integrated yet. But looking at the smart contracts and some of the as much as I can understand the EVM stuff, that is very powerful. I think it would make it easier for people to get airdrops and actually start using it in different applications.
Okay, it makes a lot of sense, and I think it's cool too. So, is this two questions? Is this a set or a series of smart contracts? And the second question is, what if how can I? So basically, to summarize this, I can front gas on behalf of my user. So I either as an individual or a company can pay the gas if I'm sending a token to somebody on their behalf. Is that correct? And then the second question to that is, can I pay with a different token other than ETH?
So if it's a hot wallet that you manage, you can front it. I don't know if you can pay with a different token. I think it's fixed to the meta transaction token. Brock, correct me if I'm wrong.
Yes, I think
it's a fancier version of the gas token from 2018. It's much fancier in my understanding.
Well, the high level abstract is instead of adding a gas fee on top of the transaction cost itself includes the fee. So if I want to reclaim an airdrop, I don't have to already have ETH in my wallet to reclaim it. I don't know if you can do other ERC20s, but I think that's the intention.
Yeah, so the idea is that the people who claim the airdrop, let's just say you have a token called dog token, whatever it's called, whatever token you want to think of. If let's just say the fees are 10%, you get 100, you would only get 90 deposited. That way, the difference would go towards the transaction itself.
Yeah, I'm amazed that this took as long as it did to be a proposal.
Yeah, there's a few things about the proposal I'm unsure. Sorry, Brock. There's a few things about the proposal I'm unsure about, like how that works from a liquidity. Like at the end of the day, you need ETH to actually process that transaction. So what is actually doing that conversion resolvement and actually liquidating that? Because there's a downward pressure there. What's actually going to take that let's say in this example, 10% or whatever the fee is, and actually pass it on to the nodes that are actually processing it, for the reward? That's my question.
Right, because it's, unless this is an upgrade to the EVM, which it doesn't feel like it is, then there still has to be gas paid in Ethereum somehow.
Somehow, somewhere.
Yeah.
Somewhere, yeah.
So that's an opportunity at the very least, right? I mean, that either has to be, hopefully this has got to be thought of somewhere in this EIP. I've gone through it, but I haven't seen that, unless it's that easy for somebody else to spin up a dApp that could do that. So yeah, you could, right? So Brock, if I wanted to, let's say this isn't included in the EIP, I want to pay with I want to pay the gas fee in I don't know, some other ERC20, right? That can't be that hard to do.
The trick is how you convert the ERC20 into ETH at time of transaction to pay the miners or the stakers now.
So how it could potentially work is that you have a smart contract that handles the transaction. It skims off the top, the 10% in this case, takes that, liquidates it, sends it to another contract which has an oracle, and depending on prices, it liquidates and then forwards that gas price to the contract that actually goes and executes the transaction. That way you have kind of like almost like a floating price point where, depending on what the price of ETH is and how many transactions you have in a pool, you execute it at a certain level. If that makes sense. The idea. So how I see it is that you have a contract whose actually the job is to execute the transaction, and that contract is connected to some type of external service that then liquidates from the contract back into the contract via an oracle.
That's exactly what they're doing. They're suggesting like a Uniswap or a Chainlink oracle to do that conversion.
Yeah, because that's the only way possible. Because to my understanding, until the EVM has some type of like external, I think it would be really cool to see within the EVM some type of external bytecode where you can trigger some type of, like, literally in the bytecode you say call just a simple get method from the bytecode, get some type of metadata, and then bring it in. That would be really cool to see. Like having some type of HTTP support, like almost like the oracles, but in a faster way, maybe is the best word to say. But that'd be really cool to see. Like if a smart contract can read live data, that'd be phenomenal. At the time of execution, though.
We're kind of working on that in a different kind of way.
Yeah.
Right, Brock?
Yep. Indexing, right?
Yeah, I don't know if that necessarily provides it at an EVM level, but yeah, we're working on real-time data.
I was telling Brock last night about smart contracts. We're discussing a result. What was it, resolvers or? Yeah, it was resolvers, I think. Something along those lines.
Yeah, you were talking about, if I was understanding it, like doing contract metadata, like verification. It's like when you're in MetaMask and you want to make sure that, this is the correct contract, you're verified in real time.
Yep, pretty much.
Well, it's crazy, John. So you know this. I didn't know this. Brock, just tell just for the audience, because John probably already knows, but about verified smart contracts. Yeah. So how are they verified today? And some of these are not very, like there's some very big project contracts that I literally was falling off my chair the other day because I thought Brock was messing with me at first.
Yeah, so contracts on chain, to add a contract, you're just submitting bytecode. So this is like hexadecimal strings, you're throwing it on chain, and the chain knows how to run that. But it's in no way human readable. It's barely machine readable. So if you want to interact with it, you need to know the original like code format, or at least something close to it, where it would say, okay, this contract has methods such as transfer token or check balance, right? You have different methods, different functions within a contract. So you need that original code, or at least the what they call the application binary interface, the ABI representation of it, in order to interact. And so, go ahead.
Which keep in mind for the listeners, is best practice in JSON, but in some cases it's not. So it's not human readable that easy. And we have that from personal experience with a zero. We remember that.
Yeah. So anyways, this bytecode's on chain, and there are now services popping up where you can verify a contract. So you can, like Etherscan is one of the big ones. So you can go on Etherscan. Hey, I just deployed this contract, and I'm going to submit the original code to Etherscan so that anybody else who wants to view it and see it, it's associated with this contract, and now they can interact with it safely because the original code has been verified. And yeah, so there's not like a EIP or a standard out there for this. It's just like big services are offering it. So there's Etherscan is a big one. There's a couple projects funded by the Ethereum Foundation. I'm sure there's lots more that I'm not aware of, but Etherscan's like the big one. And yeah, Steven and I were indexing some like NFT contracts for a customer, and one of them was the OpenSea contracts, like the main OpenSea contract where all of the millions of tokens that are like minted on OpenSea come from. It's not verified. And they did the wrong transfer call. So like the log event from transferring, it never comes from the 0 address. So it is never actually minted. So you can theoretically, there are log events on chain where you send a token from yourself to yourself.
And there's a lot of, there's people that are doing that. And the comments, Etherscan, the comments on Etherscan are crazy. You could make like a coffee table book out of the comments on Etherscan. But it's, I'm glad that nobody that has a podcast with a lot of listeners is exposing this kind of stuff, because it's like, you feel like the crypto industry is really making some serious advancements, and things like FTX are really terrible, but it's better that those things be known and these things not be as known, because these are trivial things that are like, there's no excuse for it. It's crazy.
Well, so kind of to talk about the past a little bit here, we can all remember 2018, 2019 when we were about to go launch our product, and we were deploying the smart contracts. And Stephen, you remember very well, and we could not figure out what was happening with one of our smart contracts, with our multi-sign contracts for voting, until we pointed out that the bytecode showed that it didn't return an address but a void statement. So it actually, even though the transaction method was correct, it was not, and was succeeding, it wasn't actually, it was succeeding as a method but not returning data. Thus, every downstream smart contract was broken, and we had to redeploy all our contracts. But this goes back to the idea that we couldn't really, at that time, the idea of understanding methods and understanding what was required of those methods was an issue. So contract verification is huge, especially if you're expecting a certain thing. So for EVM, if you run some type of method and you're expecting a Boolean, but it's a void, depending on how that method runs, that response in data could be equivalent, but that's not right.
Well, why wouldn't OpenSea update that contract? Is there a reason? Because they have to know about it.
It was old. That was the same case for us. It was an old contract. We didn't even know about the null.
But we identified it quick, and this was before anything could be verified, and redeployed the contract that very night.
Yeah, I remember that night quite well. But yeah, I don't know why OpenSea didn't do it, but I think that goes to the question of the tooling around smart contracts. Like I know Ganache and some of the tools around consensus has been built to help with contract verification. There's been what's the guys in Brazil who are big contract guys?
Well, hold on. Let me ask you guys this. Let's say this is a project that we've done, and we see that people are sending themselves NFTs. What would be the fix for something like this?
It depends on how the contract was deployed. Is there like a contract?
It's been deployed. I'm talking about the OpenSea contract.
Yeah, but I'm saying if that's just a single contract and everything's pointing to it, or there's a contract that's a manager pointing to it, almost like an NFT in regards to like what do you want to call it, ENS, where you point to a name and it resolves something. Is this a contract that's already been deployed and it's just that, or is there like levels to it? Because theoretically, you could redeploy it and then point it somewhere else.
Yeah, it's not proxied.
Okay, if it's not proxy, then it's kind of screwed at that point.
Yeah.
Okay.
You can't do anything about it.
You can't redeploy a new contract?
It depends on where it's stored.
Because the contract isn't proxied, it's also not upgradable. So you can deploy an entirely new one, but trying to like transfer the state over is nearly impossible. Like saying, okay, there's 2 million token holders on this contract, and we need the same token holders on this other one. There's no clean way to transfer that state. Yeah.
The only way you could do that is you have to submit to that contract as like a super admin, like changes to the contract, pretty much saying add this user to this token ID, which will cost you a shitload of money. So it's nearly impossible. So if it's not proxied, it's broken.
So it's an older contract that they deployed before verification was really a thing. And it doesn't, I mean, look, you make a mistake in a smart contract and you launch it. If you don't catch it, then it is what it is. So it doesn't seem like this is like negligence or they know about it, but there's just no need for them to incur all those costs.
Yeah, it's not necessarily breaking anything.
No. Long term, if they try to build a feature on top of it, yes, it might be very difficult to build on top of it, because just outside the fact of this issue, because it's not proxy, storage is not upgradable, like a whole bunch of things where they can't actually dynamically change the contract itself and point to different states and different proxies representing states, storage, and all those other things. From a design perspective, they, in the future, if they decide to increase their offering, they would have to migrate somehow, and it would be very painful. So that would be a future kind of pain point.
Okay. Well, let's do this. Let's break this up into a few episodes, because I want to talk about 6220, which is composable NFTs, and that'll take a whole nother episode. But I guess the last question that I have is, why isn't there a contract verification in the EVM, a proposal for it? Why is the EVM funding, separate entities to do this?
Well, I'd say the EVM and the development around it is focused on execution. So it's highly optimized bytecode to run as efficiently as possible and be the world's computer. Accessibility of that is a different concern. And so, yeah, organizations like the Ethereum Foundation attempt to tackle it, but it's not part of the core development of Ethereum itself. It's two separate things in that way.
Think of it as Web 2. Intel builds, what's an x86 instruction set, ARM. They build all these huge instruction sets, and then you have DEF CON, not the Ethereum version, but the hacker security version, where they pretty much deconstruct and prove, this happened a couple of years ago, and they said, hey, you're trying to make this faster, but look at all these instruction set with Hyperledger and all these, not Hyperledger, or is it Hypervision or whatever, they're kind of cross computing between cores. It's a security vulnerability. Their job is not to audit, but to build. I think that paradigm fits really well within this kind of situation, where for the EVM, they're just trying to build, almost like the Uber of the world, build and ask questions later. And that's the community's job, to find the holes and build around it.
Yeah, have a separate entity come in, apply AL, ML, just to basically
whatever they can
sort out this kind of stuff. And it's going to be ever evolving. It's a security, so it's complex. You can't just have a contract deployed and say, okay, it's not going to be able to do the level of scanning that an individual entity would be able to do. Makes sense.
How I like to think about it, and this is so much of a mind kind of screw with your mind, is that the more computers and the more we get more complex with technology, the more ways you can find a way to breaking into it, no matter what. Even it can, unless you have it in a ferret bag where there's no signal, there's nothing, you can't get into it. There's always going to be a way to change the hardware and the software. I think we're still at that point where even if you figure out how to manipulate a smart contract and you secure it, there'll be another way to break into that contract. You can already see it with like transaction replays and all that good jazz.
Yeah, Solidity is a double-edged sword because it's a super simple language in terms of an outsider that doesn't have a development background, but it's short, it's concise. It's like of the languages I've seen, it's one of the more beautiful ones, I think, from, again, an outside perspective, but it's also one of the most dangerous because, man, you can really, I mean, we all have a little bit of experience deploying contracts that, it just has that whatever small error that you have can be a catastrophic, or can end in a catastrophic failure or something. So anyway,
so
cool.
The one thing I would like to say to that point is that Solidity is great and all, and I've had this happen in interviews and in conversations, but because Solidity doesn't have like pre-baked features, you have to be very naive. You almost have to get one step above assembly, where you have to really, really think about the bytecode and how you're manipulating that. Because at the end of the day, that's what you're doing with the EVM. So it's that opens you up to a lot of vulnerabilities. So
cool. This has been fun. I think this year we stick to more conversations on the technical side. It's fun every now and again to poke at the news, but I think this is where we shine, and picking this stuff apart, and it's a lot more fun to talk about. So regardless of how many people listen to this thing, it would be nice to get feedback. If the 3 people that listen to this could just shoot us a message and give us some feedback, that would be wonderful. Just leave us feedback on wherever you listen to podcasts, and we'll see you next week.